You ever wonder how AI assistants like ChatGPT or Claude got so, well, behaved? How do they know not to give you dangerous advice or spit out harmful stuff? A huge piece of that puzzle comes from a single, foundational paper that back in 2021 quietly laid out the blueprint for modern AI safety. And today, we're going to unpack that exact paper. All right, so here's the plan. We're going to start by setting the scene, what I like to call the Wild West era before this paper dropped. Then we'll get into the simple but really powerful rulebook it created for AI. From there, we'll unpack the breakthrough techniques that pretty much became the industry standard, see how that all comes together into the modern AI blueprint, and then end with the big question. Is it actually enough? Okay, so let's just paint a picture of the world before this paper. Large language models were getting crazy powerful. I mean, they could write code, they could answer super complex questions, but they were also completely unpredictable. Trying to steer them was a nightmare. They could easily just go off the rails and say something harmful or just plain weird. All this raw power was a huge, huge safety challenge. This quote, it's the very first sentence of the paper. It just cuts right to the heart of the whole problem. Researchers knew these things were powerful, but that power was totally untamed. The billion-dollar question was, how do you take this general-purpose AI, an AI that can talk about literally anything, and actually align it so that it's consistently a good thing for humans? Well, the first step to solving any problem is you got to define what success even looks like, right? You can't make an AI good if you don't have a solid definition for what good even means. So the researchers at Anthropic came up with this simple but honestly brilliant framework to guide everything they're about to do. And they called it HHH, helpful, honest, and harmless. Now, this wasn't just some catchy acronym. This was a super clear set of principles. It basically gave researchers a North Star, a target to aim for when they were training their models. So instead of this vague idea of AI safety, they now had 3 distinct things they could actually try to measure. And here's the crucial part. Each one of these principles had a really concrete definition. Helpful? That means it actually does what you asked. Honest? It tells the truth, and importantly, it admits when it doesn't know something. And harmless? Well, that means avoiding offensive stuff and politely saying no to dangerous requests. All of a sudden, this abstract concept of AI alignment became a practical engineering problem you could actually work on. So now that they have the rules of the game, the researchers tried the simplest thing you could possibly imagine. What if you just told the AI how to behave? What if you just gave it a few examples of a good conversation right at the very beginning? And what's wild is that this super simple trick actually worked, surprisingly well. Look at this graph. That yellow line? That's the models that got the prompt telling them to be helpful, honest, and heartless. The red line is the model with no prompt at all. The safety scores are way higher. But look what happens on the right side. As the models get bigger, that gap just gets wider and wider. The more powerful the AI was, the better it got at listening to that initial instruction. But, just telling an AI how to act isn't going to cut it for every complex situation. The paper's real game-changing contribution was a whole new way of teaching an AI to understand not just what a good answer looks like, but why it's better than another one. And this is where things get really clever. This slide is the key to the whole thing. The old way, imitation learning, was basically like giving the AI a recipe and saying, here, copy this perfectly. But the new way, preference modeling, it's more like giving the AI 2 different dishes and having a human taste tester say, I like this one better. It teaches a way deeper understanding of what good actually means. And this is literally what it looked like in practice. It was so simple. Human reviewers would just see 2 different AI responses to the same prompt, and they just have to click A is better or B is better. That's it. This super simple format allowed them to collect millions upon millions of data points on what we humans actually prefer. And the results were just striking. You can see it right here in this graph. That blue line, that's preference modeling. It was just dramatically better on these really complex tasks. You can see how that gap just keeps getting wider and wider as the models get bigger. It was just proof that this new technique was fundamentally superior at teaching the nuances of being helpful, honest, and harmless. So this huge breakthrough, it wasn't just for some single experiment. No, this became the foundational blueprint for how pretty much every major AI assistant, from ChatGPT to Claude, is trained for safety and alignment today. The paper basically laid out this multi-stage process. First, step 1, you've got the standard pre-training, where the model just learns about the world from the internet. Then, step 2, you start training it on those general human preferences. And finally, step 3, you use all that specific A is better than B data to really fine-tune its behavior and dial it in. And this whole method, using human preferences to basically create a reward signal for the AI, that is exactly what we now call reinforcement learning from human feedback, or RLHF. It's the engine running under the hood of modern AI safety. So seriously, the next time you ask an AI a tricky question and it politely dodges a dangerous answer, you are literally seeing the legacy of this paper in action. The techniques pioneered in this paper were a monumental step forward, no question about it. They gave us the tools to make AI systems way, way safer and more aligned with what we want. But, like any great breakthrough, it also blew the doors open to even deeper and much more challenging questions. So this paper gave us a powerful how to make an AI learn from human values. But it leaves us with the ultimate and much harder what. What values should we be teaching it? When entire cultures or even just two people disagree on what is helpful or honest or harmless, whose preference wins? Aligning AI with humanity, it turns out, first requires us to figure out how to align with each other.
This is for entertainment purposes only.